Okay, so again, today is just going to be yet another review. I brought the exam from 2 years ago instead of last year, and we'll do as much of that as we can or want to. We probably won't take the entire time to get through it. But I do want to remind you that there are no partners. There's no getting, a collaboration of any kind. We do use this tool called MOS, which is Measure of Software Similarity, to detect plagiarism. So make sure that you're not doing anything that would get you flagged for anything like that. Otherwise, you will hand in 2 programs. One of them will be worth 25 points. The other one will be worth 50 points. We will be grading them like we do your hacks. So documentation, style, design, and correctness, all of those things will be taken into account. 25 points on the first one, so it'll basically be a hack. 50 points on the second one, where all the points are just simply doubled. And you can get a feel for what they're going to kind of be by taking a look at the ones that we did on Monday, and the ones that we're going to do today. The first program is to write a program to help farmers estimate the weight of corn stored in a cylindrical silo. Each silo's dimensions are measured in radius and height. So the radius of the silo in meters, the height of the silo in meters. And for the purposes of this exercise, you can assume that they're perfect cylinders. And so that's going to be pi r squared, that's the area of a circle, times the height of the cylinder, which gives you the volume, all right? That's just going to be the volume. Now, the amount of corn stored in the silo is reported as a percentage of it being full, from 0 to 1, right, on the scale of 0 to 1, 0 being 0%, 1 being 100%. So if it's half full, it's 0.5. Right? The total weight of corn then can be computed using the estimate of 720.83 kilograms per meter cubed, per cubic meter. Right? And that is an actual number that you can find in a agricultural actuarial table. I found, that's where I found this number. Right? I just didn't make this. I didn't just make this up. But this is, they had ones for dry corn and wet corn and new corn and old corn or whatever. Right? And so this is the one that I just chose. So, for example, a silo that has 5-meter radius and 20 meters high, all right, and is 35% full, 0.35, would have the following volume, almost 550 cubic meters, okay? Which would then have a total weight of, if you multiply that by 720.83, nearly 400,000 kilograms, right? Huge silo, I guess. I don't know if that's big or not. Anyway, the command line arguments will be read in using, 5, 20, and 35 for that. And you will produce a report that looks something like this. All right? Looks like we did that in the other section, so ignore that, and we will start from scratch. There we go. I'm going to go ahead and create a new file called corn.c. There we go. And like I said the other day, what you can do is you can help yourself by making sure that you've got some templates up. All right? The basic template for, again, it's not timed. You've got 24 hours, a 24-hour window, so it's not essential that you have something like this. But it does, cut down on the amount of typing that you have to type. Right? You're going to be cutting and pasting it anyway. I'm probably not going to be using the standard Boolean library, though, right? Because I'm not going to be doing. I am going to be doing some checks and stuff, but don't bring in libraries that you don't end up using. I will probably be using the math library, right? Because pi r squared, I'm going to need pi, right? So I will bring that in, and make sure that you've got full author headers here. To do author header, which includes the name, date, and purpose of a program. We're still getting folks that are missing out on 1 or 2 or all 3 of these things, right? And we are going to start taking off full points for even one of those things being gone, starting going forward. All right, I need to determine, did you give me the correct number of command line arguments? Remember that this is the radius, height, and percent. So I'm going to expect 3 command line arguments from the user, but remember that there's one at the beginning. It's always the executable file name, in this case, a.out. So I need to determine, are there 4 command line arguments? If argc is not equal to 4, then I will issue an error, printf, error, provide height, radius, height, and percent. There we go. all code post is probably going to be looking for is this keyword right here. But you should have a human readable error message there. And if that's the case, then we can't really recover. So I'm going to go ahead and exit on the program. That's the end of the program. Right? Otherwise, I do know that I have those 3 provided command line arguments. So I'm going to create one for the radius. I'm going to create one for the height. And I'm going to create one for the percent full or whatever. Right? And I need to bring those in as doubles. And why did I do doubles in radius? Even though in the handout it says 5, 20, and 0.35, right? Well, you can have a radius of 4.5 meters, right? That's perfectly fine. So the radius is going to be that. How do I convert to a double? A to F, right? Of argv sub 1. Right? And I'm going to copy pasta. I shouldn't do that, but I am. Right? And then 2, and then 3. Now I've got all those 3 values in. I can actually check to see if they're correct. What would be an incorrect value for radius? Negative, right? Folks this morning said, well, 0 is also a bad radius because you can't have a 0 radius, a line, a silo. Well, and I point out, well, yeah, but when you use it in the formula, it just comes out to 0 kilograms, right? So maybe that's not, right? We would not put that on code post unless we've specified, no, it cannot be 0 or something. So I'm just going to go ahead and go with negative. If radius is negative, or if the height is negative, that certainly is wrong, right? Or if the percent is outside of the specified range there of 0 to 1. Right? So if it's less than 0, percent is less than 0, or percent is greater than 1. And you could go 1.0 or just 1. Then all of these are going to be error conditions, error, invalid inputs. And I'll just say that one of them was invalid. If you really wanted to, you could split this out into 3 or 4 checks and then give a different error message every single time. This is all we're looking for, though, for now. Right? And then here I'll exit with a different error code. We'll talk about error codes next week. Right? All right, so now I've got good input. I need to compute all of these things. I need to compute the volume, and then the final weight. And I'll, of course, produce this little report right here, where I'm going to echo back what I read in, as well as the total volume and the total weight there. So if I want the volume and the weight to be printed, that tells me that I should probably have 2 more variables, volume and weight. Right? So what's the volume? Height times pi, so 3.14159. Is that how I should do it? Roll my own pi there? No. M underscore pi from the math library. Pi r squared, so radius times radius is probably the best, easiest way to do that. Pow raised to the power 2, that's fine too. That's going to get compiled away by the compiler though, and it's going to be translated into this anyway. Right. So there's the volume. I think we observed that the handout was wrong this morning. At least this version of the handout is wrong. So we'll bring up Wolfram Alpha there eventually to see if we're right. And then the weight is going to be the volume times, what was that number again? 720.83 kilograms per meter squared. Right? Now, is it a good idea to just have this number sitting out there with no description whatsoever? We call those magic numbers. So I'm going to go ahead and take the opportunity to define what that is. Right? Define, and what does it represent? That's 720.83 kilograms per meter per cubic meter. What would you call that? Physics majors out there? Oh, we don't know? Kilograms per meter cubed. No? Density? That's the density of corn. Right? Corn density. There we go. I'll go ahead and define the corn density to be that thing. Just like we did miles to kilometers or miles in kilometers or something. And now I don't have to worry about that weird magic number sitting out there. Let's go ahead and make sure that we're producing this report now. I'm going to replace all those values with just %fs and printfs. Printf So radius is going to be %f meters and the line. And this is radius. Then the height is going to be printf. And then I'm going to replace this with %f and the line. And this is my height. All I'm doing is echoing back the input back to the user. And then the percentage is going to be, careful here, the input is 0 to 1. So if I want it to be 0 to 100 for a human user, what would I do? Multiply by 100. So % times 100. Do I have to go 100.0? It's okay if I do, but do I have to? Nope, because there's no integer truncation issue here. It's multiplication. It's not division. You can print a blank line if you want. Generally, a code post, will ignore white space. And this is %f meters cubed and the line. And this is printf. Total weight is going to be %f. And that's kilograms. And then that's the weight. Oops, and I forgot the volume there. All right, there we go. All right, so let's see if this compiles. GCC, corn, and always compile with the wall flag just as a sanity check to make sure that there aren't any warnings there. And strictly speaking, I don't need the -lm flag here because I'm only bringing in m_pi. That's a preprocessor directive, but I'll go ahead and do it anyway. Right. No warnings, no errors. It compiles. If it was a 5-meter radius, 20-meter height, and 35% full, then we're completely wrong, looks like. Volume times corn density. Corn density should be 720. Okay, so I'm not going to take the handout's word for it. Instead, I'm going to go over here to Wolfram Alpha. That's 20 times 5 squared times pi. All right, 1570. 1570, okay. And then if I multiply that by 720, 720.83, I think that's right. All right, no scientific notation there, thank you. 1,132,000. Yeah, it looks right to me. I forget what the, I think it's right. We were getting this value this morning, but we did not get this value this morning. In any case, I don't remember what I got right or wrong there. Anyway, height, that's the volume, that's the weight, right? Oh no, what's wrong? Did I ever use my percentage? This is full, right? So here's the full volume, and I'm assuming that it's 100% full. So what do I need to do? I just need to multiply by %, because it's only 35% full. These numbers were correct, but then, there's the actual number. If I say, okay, well, only 35% of that is full, then I get 396,298. Yeah, something like that. Right? Just off a little bit. Okay. Questions on that one? Basic I/O, input and output. All right. This other one oh yeah, go ahead.
Why did you do the N again after the %? What is that?
That's meters.
Oh.
So that the output says 5.000 meters.
And then you don't need a semicolon after define, so
Nope, there is. In fact, it would be wrong because what would happen? It gets replaced with 720.83 with a semicolon there. Is that going to compile? Nope. So I'll show you that it won't compile here by putting a semicolon there. Yeah. GCC. Nope. It's not going to compile because it sees that semicolon there. Question back there? Yeah.
So you use the define
Mm-hmm.
line. Is there a difference between using define and using a constant double?
720. For this small of a program, there is no difference between these two. What this is, but practically there is a difference because this is a preprocessor directive. It will go through and copy paste and replace all of your instances of corn density with that number. That means that there won't be a variable for it. Now, at the end of the day, that data 720.83 still has to be stored in memory somewhere. So whether or not that's being stored as a static value or as a variable that you can manipulate, it's not that much of a difference for 4 bytes.
So is it like, does it like save you from if you accidentally compare like memory values?
No, I mean nothing that we get into will make a difference between these two. So this may be preferred in general, just because you're letting the preprocessor do a lot of the work for you, right? But from a practical standpoint, at least for the stuff that we'll encounter, there's no difference. But you can see here that if I try to do this, I think twice, yeah, okay. So this as is definitely is not going to compile, because what it's going to do is it's going to come here and change this to 720.83, and that's not a very valid variable name. So I can show you that it won't compile there either. Right, there we go. Corn density has been replaced with 723 there, 720 some. So let's go ahead and get rid of this and show you that now it will compile. Right, but that because I put a constant in front of it, corn density equals 2. Right, that any attempts to change it will also be a compiler error, because I declared it as constant, and therefore you cannot change it. So 6 of one, half a dozen of the other, for our purposes. Let me get rid of that though. Okay. All right. So the second exercise here is going to be very familiar. It is basically a FizzBuzz program, but it's more generalized. Your program will read in 3 integers A, B, and N as command line arguments, and output integers 1 through N, 1 to a line. However, if the number is divisible by A, it would output Go Huskers instead, Fizz. And if it's divisible by B, it should output Go Mavs up in Omaha instead of the number. And if it's divisible by both A and B, then it should output Go Nebraska instead. Okay. Put your program in a source file named cheer. Right. Question online, will the execution of speed be the same as if numbers were larger? No, I don't think so. I don't think that there's going to be an appreciable, at least again on the stuff that we're looking at, I don't think that there's going to be a performance issue between these two options here. So let me go ahead and get rid of that and start fresh. Right. New file, what was it, cheer.c. Right, there we go. And I am going to steal all of my stuff up here. I'm going to just steal this stuff right here. Right, there we go. To do, again, author header. The name, the date, and the purpose is all required. Okay. I'm probably going to be doing some math, but I'm not going to be doing fancy math stuff like sine, cosine, square root. So I'm going to go ahead and get rid of that. If you leave in libraries that are not used, that's cruft, right? That's clutter. You should not bring in those libraries if you're not going to use them. But standard library also should probably go first, but that's just a small style issue. I should also probably steal int main blah blah blah, right? And return 0 at the bottom. Okay. So same stuff. I'm going to read in A, B, and N. So int A. I'm going to put up a to do here. To do. Check for the. Actually, let's do it. We've got enough time. Let's not get lazy. Right. I need to check, did I get enough command line arguments? If argc is not equal to what in this case? I need to read in A, B, and N. So it's going to be 4, right? Because of that first one, as always, a.out. If I'm going to execute it like this, where's the, oh, there's no example here, but a.out, A, B, and N, that's 4 command line arguments. So if it's not equal to 4, then I'm going to issue the same error message that I did here. I don't like typing, so I'm going to go ahead and grab that stuff. There. Okay. Otherwise, I can read it in. Now, before I used A to F because it was a floating point number. What am I going to use now because it's an integer? A to I, right? A to I. Arg v sub 1. Copy, oops. Copy pasta. Don't do that. But until you get quick about it and thorough about it. 1, 2, and 3. Right? Now I've got A, B, and N. Do some basic error checking here. Can you divide by 0? Nope. So if A is less than 1, or I could divide by 1, but then everything is divisible by 1, and I'd always be outputting go Huskers or go Mavs, and that's ill-defined. So I'll say if it's less than 2. Right? 2 is okay. 0 is definitely not okay. 1 is questionable. Negative values, I don't even want to deal with that. If A is less than 1, or if B is less than 2, or now n here is different. Remember, I'm printing out numbers 1 to n. So if it's less than 1 there, then it's going to be an error. Or you could say that that's not an error and it just won't print anything out. Numbers 1 to -5, right, it wouldn't print out anything. Here I'll go ahead and say printf error invalid input. Exit 2. Right. Basic input validation there. Okay. Now all I have to do is reference my notes back to the FizzBuzz, right? I'm going to do a for loop because I know exactly how many iterations I'm going to go. I'm going to start at 1. I'm going to go up to and include n, and I'm going to go by increments of 1. An idiomatic for loop. Now remember that if it's divisible by A, I output go Huskers, B by go Mavs, and if it's divisible by both, I output go Nebraska. Which one of those conditions should I check for first? Both A and B, because that's the most specific. If I mod n, or sorry, I mod A is equal to 0, it has a remainder of 0, and I mod B, it's divisible by B, it has a remainder of 0, then I'll say printf go Nebraska. We can both be winners. We don't compete in much, although basketball. They have a really good soccer team. UNO does. They did have a good baseball team for a while. Not so much last year, but they consistently beat us 2 years ago. Right? Else, okay, but whatever. Great. Basketball. That's it, right? All right. So else if I mod A is equal to 0, then I'll print. It was go Huskers, I think, for A, and then else if I mod B has a remainder of 0, then I will output go Mavs. Go Mavs, or Mavs. There we go, Mavericks. Else, what's the most general case here? It's not divisible by either one, so I end up printing the number, %d, and the line I. Right. Once again, let's make sure that we're using the wall flag on this for our cheer wall. There we go. Run it. Oh, provide. Oops, sorry, not. This is cheer, right? GCC cheer wall. Oh, okay. Terrible error message there. Provide A, B, N. That's why I was confused. Thank you. All right, there we go. Let's do the traditional FizzBuzz, which is 3, 5, and then 100. Right? Then we'll be looking at multiples of 3, multiples of 5, and then 15 should be our first go Nebraska there. So let's go all the way up to the top here and see if it works. There, 3, go Huskers. 5, go Mavs. 6, go Huskers again because 6 is divisible by 3. If I just jump down here, the first instance of go Nebraska is 15. This is exactly what FizzBuzz was about, except for Fizz and Buzz and Huskers and Mavs. All right, so if you missed Monday's review, I would encourage you to go back and watch the live stream because arguably those two programs were maybe 10% a little bit harder. Honestly, I forget what I wrote the exam 2 weeks ago, so I don't remember what the what they are. But when I do it, I of course time myself, and then I apply a multiplier of 4 or 5. I got it done in 10 minutes, and so go map that out to an hour. Then I gave it to a learning assistant. I apply a multiplier of 2 there, and so they got it done in a half hour. In fact, they got Java and C versions done in a half hour, and so it's definitely doable in an hour. You see the kind of level of difficulty. Less probably than a hack, slightly more than a lab maybe, and you have a 24-hour window. No collaboration, please. No, we will be using MOS as a measure of software similarity plagiarism detection tool. No use of tools, AI tools or whatever. Again, if you're resorting to those kind of tools in the first 4 weeks of your first CS course, consider a different major. Right. All right. Any questions? Yeah.
Are we allowed to like look at our previous programs that we've made?
Oh yeah. So if you're not aware of it, we have guidelines, and they're just common sense guidelines. And I do want to show you the explicit guidelines though, documents, code usage guidelines here. Come on, please render. Okay, it's not going to render because it's a PDF. Darn it. I can bring it up though. Come on, shared. Documents. Here's the code usage. I don't know why they stopped rendering PDFs on GitHub, but whatever. All right, so acceptable code use. Right, labs required collaboration. We're expecting people to hand in the same stuff. Hacks is open collaboration, two pairs. So we're expecting pairs to be the same, but this pair over here and this pair over here, we're not expecting those to be the same. And then exams is closed collaboration. Specifically acceptable code use, any function provided as part of the language standard library. It is not cheating to use printf, right? You have to use printf. It is not cheating to use sqrt in the math library. Any piece of code that was provided to you by the instructor. So if I give you starter code, great, use it. If I give you code in your labs or in your hacks or or in lecture, like when I post this stuff, freely use it if you want. Right? Any piece of code that you wrote as part of a lab, a hack, or another assignment, you can use those. Yeah.
So in the past hacks and labs, you were able to check it and see which parts you were missing, and then you'd see where your error was and how to fix that. Is this similar?
Yeah, you'll be submitting it on to Code Post, and there'll be 5 or 6 test cases. Oh yeah, 20 as many times as you want over that 24-hour period. Do not start at 11 p.m. Right? If you have computer troubles, fine, get to the lab. It's open 24/7 with your N card, right? But otherwise, those and then the last one would be any piece of code you wrote outside of the class for another class. And this has come up before because somebody wrote some code for my class and then used it in another class, and that instructor contacted me and said, "Did they actually write this code?" Yeah, that's part of that was their assignment. So no, that's not cheating. Unacceptable code use, of course, would be using ChatGPT or Copilot or something like that, copying from Chegg or copying from what's the other? All of these here, whatever. Soliciting another student or somebody outside to do your work for you. None of that is acceptable. That's obvious, right? Hopefully that's obvious, right? And then don't be stupid because, don't give code out. Many people have, given code out thinking, oh, they're not going to use it. Or the person says, oh, lend me your code. I just want to see how it works. No, I won't turn it in. They turn it in, right? And guess what? Then they're both implicated and they're both screwed. Don't trust anybody, right? Don't trust them as far as you can throw them, right? Don't copy code off the internet because you know what? If you're going to copy, somebody else had that brilliant idea too, and they're going to copy and they're going to match, right? And I can Google too, I'm going to be filling out some DCMA or Digital Millennium Copyright, DMCA, the DMCA takedown requests on some stuff that I found. And again, several other idiots have the exact bright idea to do this, and you will be caught. So again, proper collaboration. There is no collaboration on exams, so the proper collaboration is don't talk to anybody until after you're done. Right? I wouldn't even talk to them about anything until after midnight on Friday evening. Right? And then you could say, oh, that was easy. What did you do on this? Did you do a const or did you do a preprocessor directive? Right? Well, I did a preprocessor directive. Right? Something, whatever. Right? So yeah, anything that you've written in any as part of this class, you can use it. Any other questions? I have 20 minutes. I've got other exams, but they were midterms, so they cover stuff that we have not covered yet. I'm not going to do that then. Yeah.
Can we use the debugger or not?
Oh yeah, yeah. Well, what do you mean debugger? You mean the chat the
Yeah.
what do they call the duck? The duck debugger? Yeah, sure. It's not going to give you code, right? What's wrong with my code? Let's go back to corn and say, all right, corn density is equal to 2. All right, I'll just copy that. There. Looks like you're trying to reassign a value to a constant variable. In most programming languages, constants cannot be changed after they've been initialized. What do you think you should do if you if you need a variable that can change its value? All right. It's kind of condescending there. I don't know. Be less condescending if that's how you spell it. Oh, now, okay. I got it to give me an actual solution there. I made it feel bad, yes. All right, so good luck on this exam and any other midterms that you have, even though it's 1/3 of the way through. We will be posting, hopefully Hack 4 will be graded on the Friday at some point, or as early as possible. And then we'll post a mid-milestone retrospective on grades and such. All right.